Hello everyone, in this one we're going to be going over how to hook Dx11 using the Steam overlay. This is in 64-bit, whereas last time I did it in x86. Everything will remain the same. Obviously just with 32 extra bits. I hope you enjoy. I've recorded this video 3 times. This video was recorded once with a voiceover and my footage was corrupted, so I couldn't do it. And now I've just recorded all of this video with a massive echo through 2 microphones, so obviously can't release that. So now I'm just going to be doing another voiceover, just going over, speaking through what I've previously just been doing on this here. So I hope you enjoy. So right off the bat, all I'm going through here is just explaining sort of how I've gone and found out things. Again, it's pretty simple. As you can see, there's some name functions. I've already been through this a few times, and by this point already broken. But all I've done there is gone from the entry point and just found the main thread where everything's sort of happening. And all I'm just going to describe now is just sort of what the key things we will look out for. If you watch the first video, it's very similar there. We're looking for key functions like hooking functions, and I'm just going through now that I didn't notice this before, but the Steam overlay module, it actually does its own login function, which can also be another way in for us potentially. If we go through those logs and see what strings are there, we potentially find a way in there. Potentially it's failed to do something, creating a device, or something's gone wrong, and it's given us a key error message that only exists when doing particular functions that might be of interest to us. So just things to note when you're looking at other things as well. There's much more than one way to do something, but all my aim is here now is just going through the main thread, and I'm just looking for a hooking function, because we already know that this version of the module in x86 is a hooking function in the main thread, and they're not going to reinvent the wheel, so that's all we're going to look for here. And once we've found that, we're just going to retrace our steps. Again, in the last video I sort of said that you can use cross-referencing if you wanted to. You could step through each of these functions until you find something interesting. In this case I didn't do that. I decided to use strings instead. Which eventually you're going to see in a second. Found a pretty interesting string, and that is what led me to where we need to be. So as you can see right now, I've just found our hooking function, and I was just explaining, going over that how do we sort of know that this is what we need it to be. If we couldn't spot that from the naked eye, I'd step into the function as we've done it, and we can see straight away it is a hooking function. It's telling us it's a trampoline, it can't do it. That's obviously what it's doing, and that is of interest to us. That is where we want to go. And right now, as I said before, if you really wanted to, you can use cross references. You can step through all these functions, and you can potentially find key points of interest there if you really want to do it that way. There's not one set way to achieve any goal. That is one way of doing it, potentially a bit slower, more methodical, but it works nonetheless. So now all we're going to do is just going to use strings, and we're just going to go through here, and we're going to search for key phrases and things like that we might pique our interest. Again, if we look through these strings without even searching for what we might think pique our interest, we could find other things that potentially are of interest to us. As you can see here in this case, that first string there wasn't of interest to us, but in a second you're going to see something that I've got quite lucky with. In Dx11, obviously we've changed it. It changes a little bit of technology stacks, and instead of looking for device things like that, we want to look for a thing called swap change, which is what DirectX11 uses for rendering. In this case, that's all I've done. So all I've done here is look, we found a vtable, mention of a vtable and swap change. That's exactly where we want to be. So we're going to go straight in there and have a look and see where it takes us. And it just so happens that this is the place where we want to be. So as you can see there, seeing where it's sort of referencing in one place and where this string is coming from. And in this function, this is doing something where it's basically hooking the vtables and the swap chains, which is of great interest to us. And I'm just going over sort of saying why this function is going to be of interest and pique our interest, because you can see straight away there the function arguments and some of the variables inside the function, all referencing vtables, which is exactly what we want. As we know, obviously vtables are generally going to be double pointers dereferenced, so that's going to pique our eye straight away. And as you can see there as well, we just found our present function. Obviously it's named, so it makes things a little bit easier, but now I'm just describing basically that if we didn't know it was named, how would we know it is our present function? So basically there's what we're going to do is we're going to go step into the function, and we will then check and see what sort of parameters it has, and we'll compare that with the present function that we know. So this present function takes two parameters, both of them being integers, one for flags and one for synchronized frames, and then it'll also take a hidden parameter, and that's really this pointer. And as you can see in a second, that function exactly matches that prototype, so that is where we want to be. All I'm doing now is just changing these variable types to sort of fit a vtable. As you can see straight away, I got the wrong type, so I initially thought that this was the Dx11 device, whereas obviously the rendering doesn't occur there. We're on the right track because I just sort of figuring out these RB tables and it's going through and figuring stuff out, but we need to give IDA a little bit more of a prod. Obviously not going to do everything for us, so all I've done is I've gone back and sort of used my brain and thought, oh, where does the render actually occur? We have a few different key points of interest, one of them being the Dx11 device, which I've first tried and doesn't look quite right. So now all we're going to do is change its type to the swap chains type, which is another piece of the puzzle. It's created when you create your device and swap chains. As you can see straight away, we found our present function right there, and as I've just said before, we're also going to verify that to ensure that this is correct, and upon verification we can see that does appear to be correct. We can also go in a dynamic debugger like x64 debug and also verify this as well if we wanted to, and as you can see the function prototypes there match straight away, so we're on a pretty good hit here. We can say with good confidence that this is going to be our present function hook. All I'm going through here is just explaining some sort of key things with reverse engineering. One of them being, don't make the puzzle piece fit. If it doesn't fit, it doesn't fit. Don't try and make it fit. It's a good thing with life as well. If something's not working, or in general with a lot of things, don't try and make things work. If it don't work or things like that, it's not going to be it. And the key concept in reverse engineering, don't make it fit. Wait till you are absolutely certain and you find something that absolutely matches. As you can see there, we've stepped into a function. If we thought it was present, it absolutely cannot be, without a shadow of a doubt, because it only takes one function parameter. How can it possibly be present? And that's sort of how we're going to narrow it down through trial and error, and just sort of what things are possible with the information that we have. And obviously, while I've got a rich SDK such as DirectX, it's going to make it a lot easier for us to determine what is and what isn't what we want. Right now, all I'm doing is just explaining our methodology. So we're basically going to overwrite the hook. We're going to hook the Steam hooking function, which is hooking the present function, and we're going to redirect the execution flow from the hooked function that Steam uses into our own function. Just as we did before, not reinventing the wheel, we're using the tools that are given to us, so nice and easy. Right, so all we're going to do now is just going to go through the code line by line, just sort of going over how we're going to achieve what we want to do. It's not going to be great in depth in this video. If you want to see more of an in-depth explanation, go watch the old x86 video. The concepts are exactly the same, and it's covered a bit more in depth in there. Nonetheless, we're just going to go over it really quick, just to achieve or how we're going to basically do what we're going to do basically. So right away, obviously, we declare our function prototype for our hooking function, which parameters there. Yeah, that's sort of the main priority that we need. Obviously need that to hook our functions, and then obviously there we're declaring another function prototype, which is going to be the pointer to the present function inside the game overlay in the module. That is basically their hooking function, and then there's our hooking function, which is going to return to the original function there. So obviously when the return function is executed, it basically just jumps to an address that it's given. So all we're saying there is jump to the original present function. That's why you'd use function prototypes in that manner there. So in here the code is very simple. It can be, as you can see, that can be achieved in like 4 lines of code. In theory, the hook that we're actually doing. So right away we're just getting the necessary bits. So obviously our module base, because obviously we need to know what we're going to calculate from. So right away there, we're just going to get our hooking function address, which is going to be the function pointer to the hooking function that Steam uses. This is going to allow us to obviously hook the functions just like they do. And then the second one there being the present function address is just going to be the Steam's present function. We need that one because obviously that's the function that we're going to hook and redirect execution from. Really quick, I'm just going over here sort of how we'd get these offsets and just sort of going over rebasing. So if you wanted to in IDA, if you're using that, you can do a thing called rebasing, which is basically just going to rebase or reset sort of the structure of the program in terms of maths, where everything's laid out in memory. this makes it a little bit easier. If you're calculating offsets, because if you're going from 0, it's going to be a relative offset. If you don't want to do that for whatever reason, obviously, if you've got a really big program, this can take a potential while. You do a bit quick math, you take the module base and you can minus sort of where the program that's loaded into memory from there, and that'll give you the same thing if you want to do it that way. All we're doing here is just sort of taking our function prototype, and then we're just using decl type to declare a function pointer. So that'll make it so hooking function, instead of being a variable, is now pointing to a function, and that's what we're going to use to actually hook our functions there. And as you can see straight away there, the first argument that we are taking is going to be the address to the original present function inside the Steam module, and then we're going to want our hooking function, so our present hook function up the top there. Our third argument is going to be the return address. So this is taking it by reference, as you can see there, and it's just going to put the address of the original function into that variable there, our function prototype, and then we are going to be returning via a jump instruction to that piece of code in memory there when we execute our hook function. And finally, the last parameter, I'm not too sure what it is, but it's just called the same in each one, either a 0 or a 1. So we're just going to do that exactly as Steam does it, so to make sure it works. All I'm going through now is basically just what we've done. So we're not actually drawing in this video. I don't have any on hand, but in another future video that'll be covered. But in this case, we're just using print, but we're going to show in x64 debug just to verify that it is in fact actually working. Right, so all we're going to do here is just inject the DLL that we've made, just to verify that obviously our hook is working. Happy days, as you can see there, present is hooked, and we'll verify that. We'll go into x64 debug and we'll just step through and we'll see our hook in real time. Where is Dishonored 2? Here we go. Do we already have? We do. We already have a hook on swap chain present. So now if we follow this hook, it should take us back into our module. What module are we in? Game overlay renderer. Jump through it. What module are we in now? Happy days. As you can see, we're in a different module now. Here we go. There we go. We are in our module somewhere. There we go. As you can see, from ours there, present hooked, nice little print off there, just helps us identify it. But that is our function once we step through it. As you can see, all nice and well, we're not drawing, but we've stepped through it in the debugger, so you can see it is working as intended. And that's all there is to it. If you want to know a more in-depth, or have a more in-depth explanation, please go watch the old video. I don't want to repeat myself, but it is relatively simple. But if you need a bit more guidance on it, I'd recommend you watch that. Thank you very much for watching.